All right, so, all right, cool. All right, so this week, our GBM talk is an intro on binary exploitation. So who am I quickly? I am a third-year CS major. I also run the Colonel Sanders CTF team. And in my free time, I do security research on the Linux kernel. So a bit of prereqs for this talk. Some knowledge about assembly and RE will be helpful, specifically about like how the stack works. About how the stack works, and also some experience writing C and C++. And more importantly, a will to actually kind of try harder, to actually like persevere and like go through this, because it is a very thick topic. And which also brings me to the disclaimer: binary exploitation is it can be very difficult. So which is why this talk for this week will be a very surface level discussion about binary exploitation. And next week I'll go into a little more about how the state of it in the modern day, like 2022. But despite that, binary exploitation can be very hard. It can be very fun. And it does require a different frame of thinking, but I guarantee it that if you stick with it, you will be rewarded in the end. So PWN, or binary exploitation generally, is exploiting bugs in software. And those bugs can be exploited to gain local privilege escalation, which allows you to go from normal user to root without knowing any kind of admin password. And you can also defeat system defenses that are supposed to stand in your way to exploit binaries. And you can also achieve arbitrary code execution, which is the holy grail of software bugs, because you can execute anything that you want on a target. You can steal files, or even plant like backdoors for later access, anything. You can do whatever you want. And the goal here for CTFs is to pop a shell, aka you're calling system bin sh somehow. That would be an example. So why even learn this? For one, you get to create your own software exploits. That would be fun. And you can even learn how to write secure code, so that way your own like software projects aren't being exploited in the wild. And also when you're learning PWN, you can even gain employment as a security researcher by as a security researcher, your job is to find and exploit bugs for a living. So quick thing, this is our first example. We have a little C program that's about 30 lines. And right now on the left, we have the stack and how all the variables on the stack are laid out. And here's what we need to do. So right here so we have our two stack variables, a character buffer of size 10 and an integer. And so right now on line 12, that change me integer is set to 0. But down below, if it's not 0, if we change that at all, we get a nice welcome message and we get system bin sh. Now in between, we have a printf that tells us what the contents of our variables are. And on line 17, that just removes the new line character. So that way I can have like this nice pretty chart. But yeah, down at this if statement, if we haven't changed it, we just get a little thing that says, oh, still not there, try harder. So I'm going to I'm just going to show a live demo quickly. Oh yeah, wait. Oh, hold on. All right, cool. All right, so we have that stack program. And if we just start inputting a bunch of A's, as we saw on the fgets line, on line 15, where it allows us to send 1,000 characters to the character buffer. from the console. So if we only input like, I mean, it's like 8, we see that our buffer only has like 8 characters and change me still 0. But what if we just keep inputting a little more, right? Bam, change me is now like 16,700 whatever, and we're even given a shell because we hit the system bin sh. So the bug in this case was that we're able to send 1,000 characters into a buffer that's only of size 10, right? That's like 100x what we're supposed to. Now, for Pwn, the game here is like we're finding bugs. And again, the bug here was that, 1,000 bytes into a 10 chart character array. That's not supposed to happen at all. And now we know that we can use this fgets bug to send large amounts of input to the program. Now, what kind of input can we send in? Well, in this next example we have, the stack is still the same as normal, but now we're taking input in by a command line argument into something called, and the command line argument is taken from, it's a parameter to a function called stir copy, and it's taking our contents of the first parameter and putting it into the buffer. Now, an interesting property of stir copy is that there's no size restriction until it hits a null byte, right? So until it hits a null byte, we can send whatever the hell we want. And now you see down here on line 21, is trying to check if change me is equal to a value hex deadbeef. Obviously, that's not ASCII, so how exactly can we change it to be hex deadbeef? Well, there's a way. So if we go to this, okay, yeah, so we see here if we do no arguments, we have to provide one. So we're going to use the power of Python here. Python 2-c. So we're going to send it 15 A's, right? So -c argument basically is like, command line Python, so we can actually use it, as like a normal command. Hold on. Oh, yeah, I forgot print. Yeah, we need to print it. So we do that, 15 A's, still not there, try harder. So what if we could escape one of these characters, like make a character that we just escape it? All right, we just do DE. Yeah, Ben? For stir copy? Only if we're trying to hit the return pointer. We're not, we're trying to change a variable on the stack. So if we were trying to like go to another function in the program, yeah, that would be a problem. And we would use another bug to leak it, but that is actually something for next week. So if we EF. So if we have our little Python exploit to be like this, so where we're just printing like 10 characters, and then we also have escaped, deadbeef our hex value. We hit enter, still not there, try harder. So we just got adjusted a bit. There likely is some padding that was added by the Clang compiler. And now we have it, well done. There you go. Yeah, thanks, Cole. So a big part about binary exploitation is that you have to have a methodology, right? You have to have a way of approaching like these problems to find the bugs and more importantly, even landing them, right? And part of that methodology is that you have to have an adversarial mindset. You're the attacker here. Like a nice equivalent would be that you're like scoping out a bank to rob. And so like you're checking like, okay, can I get in by the back door? How good is the vault? Is there any employees I can bribe? So on and so forth. And a part of that process is that you have assumptions about the program, what it does, how it does it, what kind of data it's touching, what's it manipulating. And you're always asking those questions of, are those assumptions valid, right? And a part of that methodology is that you have to get creative, right? You have to really think out of the box. And for that methodology, a part of that process is that you'll recognize patterns, right? Like, for example, you're seeing mentions of known vulnerable C library functions like strcpy, memcopy, memset, gets even, and gets, by the way, unlimited input until like return, I believe. And also another good pattern is bad pointer management, like code that is not checking if like your pointer is null, because that's actually exploitable. I can talk about that next week. And another part of this methodology is that you'll use your tools to create scripts and actually make your own tools to find bugs and also help you even land them during the exploitation process. And if you keep sticking with it, over time, you will get comfortable and you will like have more confidence in actually landing these bugs. So some recommended tools that I have if you're going to get into binary exploitation, you need a good disassembler. I highly recommend Ghidra, which is a free and nice open source tool from the great men and women at Fort Meade, Maryland. There's also Binary Ninja, which does IL-based analysis. But one part of Binary Ninja that I love a lot is that the Python API, highly scriptable. In fact, it's incredibly modular because all you need to have in order to use the API is quite literally go in the Python interpreter, import Binary Ninja. That's it. And also I have to mention IDA Pro, which is the most popular of these three. And it is the oldest with, I think it came out in like the early to late 90s. 91, damn. However, though, it's expensive. I think it's like $1,000 now. Just totally do not recommend that. Though obviously, if you're going to debug your exploits, you're going to need something to actually debug them. So I highly recommend if you're going to be on Linux, use GDB. And if you're going to use GDB, use Jeff, PwnDebug, or PETA, which are wrappers for GDB. That'll actually simplify the process heavily and actually give you more power when debugging your exploits. And if you're on OS X, I highly recommend LLDB, because if you do anything with Xcode, that's what you have. And you can also get it on Linux too, thanks to Clang people. If you're also doing this on Windows, WinDebug is the best, though, and it also has the ability to do kernel debugging. So if you're on if you don't like WinDebug's UI like I do, there's always X32 and X64 debug. Yeah.
What's a wrapper?
Wrapper is just, in GDB's case, it's just a Python script that adds more functionality, right? Yeah, like more commands to help you simplify the process. Like on Jeff, one command that it gives you is search pattern, which searches the entirety of memory using the pattern that you specify. So it's great for finding like your the payload that you're sending in your exploit scripts, especially if you want to determine like offsets between like where you're starting your input and where like your target stack variable is. Yeah. And if you're doing CTFs, highly recommend Pwn Tools, which is a nice Python library for working on CTF Pwn problems. And it gives you like a nice environmental framework. So that way you don't have to focus on all the background stuff associated with Pwn or associated with like, getting the environment set up, that you only focus on landing that exploit. And it gives you like nice helper functions too, like endianness packers, file analysis, even helps you generate ROP chains and shellcode that, again, I'll explain next week. Now for resources you want to get started, highly recommend Guy in a Tuxedo's Nightmare course. I actually know the guy. He makes really good stuff. And it's been highly rated by a lot of people who work in the industry. It's a great resource to get started. I also recommend Pwnable.kr, which is a website that gives you beginner-ish CTF problems, or not CTF, but they're more, yeah, they're Pwn problems, and they start out very easy, but there are harder ones like later down in the series, and there are a lot of them. Though if you want to start out with a little harder one, there's Pwnable XYZ, which styles itself as hard CTF problems. I also recommend looking at Live Overflow on YouTube. He makes some good videos about how to do like very advanced exploit techniques like heap and even ROP. But those bugs are more stylized like on the 90s stuff. And also the UFSIT Discord server. We have a lot of great people who do binary exploitation, who are still in the club and even work in industry. Feel free to just ask a question and one of them will, will help you give you like a great answer. So any questions? No? All right, thanks.